dealing with radicals. Sorry, it's a nasty day out. Anyway, so radicals are obviously the square root sign, and we got to get rid of it in order to solve and verify. Verify is going to come in later. What it basically means is when you got your answer, is it actually going to work? So we're going to plug it back in and see if that's a correct answer or not. The problem being most of the time with square roots that you can't have a negative under the square root. So once in a while you'll have an answer that doesn't quite work out. So we have to test them. So the first thing that we want to look at is how are we going to get rid of this radical? And the easiest way to do that is to square it. You square a square root and then the square root disappears. But we don't want to do that in a messy way, so we don't want to have to square this whole thing because then this is going to cause a problem. So what we do instead is we're going to move this over to there. And since it's a negative one, it becomes a positive one. So I'm going to rewrite my equation. All I've got on this side is square root x plus 3 equals x plus 1. So now I can square this and I can square that, and it's pretty straightforward. So I'm going to do that, square that, square that. This just becomes x plus 3, so it gets simpler. This one gets a little more complicated, but it's not going to be too big of a deal because we know that we can just FOIL it. So I'll write it out as x plus 1 times x plus 1, and the x plus 3 just stays here. We go x squared plus 1. So I'm just going to do this in a quicker way. I know that I've got my middle terms, 1x, they're going to equal 2x, so I'm going to be left with x squared plus 2x plus 1 on that side. Now that I've got them all like this, I can put them all on one side of the equation, make the other side equal to 0 and solve. So I'm going to move these guys over because I don't want to make a negative x squared, so I want to leave him on this side. So the x is going to come over here and become negative x, like that. And the number can go over to this side, or I could just put them all on the one side and make it equal to 0. In this case, I think it's just easier to make everything on this side equal to 0, factor it, move on. So the 3 is going to come across. It's a positive 3, so it's going to be a negative 3 as it comes across, and I'm left with that equation. So I make the whole thing equal to 0 because I left nothing behind. I've got x squared, positive 2x and negative x gives me positive 1x, and positive 1 and negative 3 gets me negative 2. So this is a pretty simple thing to factor because I've got just an x squared, so I just write my x's there. I need to have 2 there and a 1 here, so I can write the factors of negative 2 are just 2 and 1. Whoops, that's a 1. And this has to be positive, so the big number needs to be positive. That means that's a negative 1. So I can write x minus 1, x plus 2. And that means that this x value, if the whole thing is equal to 0, is going to be 1 because 1 minus 1 equals 0. And this x value is going to be negative 2 because negative 2 plus 2 equals 0. So I've solved over here that I could have a 1 or a negative 2 as my answer. So what I want to do is take the original equation now, plug those numbers in, and see if they work. So I'm going to do this one in blue. I'm going to write this whole thing out. 1 plus 3 minus 1 equals 1. Does that work? So the square root of 4 minus 1 equals 1. Square root of 4 is 2. Minus 1 equals 1. Yes, it works. I'm going to do the next one in green. X equals negative 2. So I write negative 2 plus 3 minus 1. Notice that the minus 1 is outside the root sign. Don't make that mistake. Equals negative 2. Well, negative 2 plus 3 is root 1 minus 1 equals negative 2. this is where it gets a little bit tricky, because I'm going to assume that the square root of 1 is just 1. You might be tempted to argue that, well, negative 1 times negative 1 is also this 1. So if I had negative 1 and negative 1, it would equal negative 2. Your book always assumes a positive answer. So they're going to say the square root of 1 is 1, minus 1 equals 0, which does not equal negative 2. And so this is where your book and I kind of tend to not agree 100%, because that's not mathematically necessarily correct. I think what they're doing at this stage is just trying to keep it simple and say, okay, the square root of 1, if you put it in your calculator, will give you positive 1. So put that into your equation and see. This way it doesn't work, so we call this an extraneous root. Because we put in negative 2 and it didn't clearly give us the right answer, this is an extraneous root. It means it's an answer, but it's not a real simple one. So we get rid of it. We go, you know what, we're just going to take the one that worked without any questions asked. Good to go.